Power series, page 145, are we good? Okay, a power series, here's my definition of power series. It's an infinitely long polynomial. You know how you can have a third degree polynomial that goes up to the x to the third, or you can have a seventh degree polynomial that goes up to x to the seventh. A power series has an infinitely long, it just keeps going. It has x to the 1, x to the 2, x to the 3, and it goes on forever. And it turns out that a lot of functions that we know can be written as power series, and that's how computers actually do a lot of the work that they do, is they write them as these long polynomials as opposed to these messy functions. So some definitions. We talked about power series centered at 0, meaning 0 is in the middle of it in terms of, if you think like of quadratics, you know, you can have y equals x squared, and you can have y equals x minus 7 squared. And this moves the vertex over to 7, x equals 7, right? So, but if it's like this, the vertex is at 0. So it's the same kind of idea. This is centered at 0, this is centered at 7, the middle of your, if it was a parabola. So centered at 0 always have this form. They just look like some generic polynomial where you have some constant in front of powers of x. And the constants could be anything. Here's an example of one. Let me put it in a different color. Put this an example. An example of one might be 5 plus 3x plus 9x squared minus 7x cubed minus the square root of 3x to the 4th. And it's just going to go on forever. But what it is starting with n equals 0. So when n equals 0, I have C0 we call it. That's the first constant, C0. The C0 is 5. And what's x to the 0? 1. So this is 5 times 1. And then I'll have C1, my next constant, which turns out to be 3 in this case. Another constant times x to the 1. And another constant times x squared. And another constant times x cubed, and so forth. How we get these constants we're going to talk about later. This is just an example of one. Okay, it's notation, what it means. Just starting with constants and going up with powers of x. This is the same idea, except that now you have x minus some a. And a could be anything. So maybe I'll have one centered at 4. 2 plus 7 times x minus 4. Minus 19 times x minus 4 squared. Plus 27 x minus 4 cubed. Minus pi times x minus 4 to the 4th. These are just examples of what it would look like. So these are powers of x with constants in front. These are powers of x minus 4 with constants in front. That's what we mean by centered at a versus centered at 0. And so the question still is the same. What makes these harder is now not only do you have series, but you also have variables in them. It was hard enough when they just had numbers in them with some n's. But now we've got n's and we've got variables. So the question becomes, for what variables will these series converge? Will it converge if x equals 3? Will it converge if x equals 9? Which x's will make it converge? And that's where we talk about the interval of convergence. Without an example, I can't quite totally show you what that is. But for some values, the series will converge, for some x values, and for some that they won't. And so we're going to describe what the x values are that make it converge. Now I'm actually going to show you an example of that first, before we go on to the rest of this vocabulary. So let's just look down at, let's do a real generic one. Down there at the bottom, maybe underneath the notes where it says number 5. I'm going to put a real simple polynomial, power series centered at 0, where every constant is 1. Right? It's one of these, but every constant happens to be 1. What is the shorthand way I can write this series? Just made this one up.
X to the
X to the n, right? This is x to the 0, x to the 1, x squared, x cubed, so forth. Notice the power series, we almost always start at 0. Now this kind of looks familiar based on what we were talking about earlier with our review. Does this look like a series we already know? Some of you knew what they kind of looked like, but if it was like a P series or a geometric or a harmonic, or does this look like something we already know?
Geometric.
It looks like it's geometric, because every time you're multiplying by another x, it just turns out that our common ratio of r here is a variable. So this is geometric. And our common ratio is x, right? We multiply by x every time. And what makes a geometric series converge?
R is less than 1.
You're close. It's technically the absolute value of r is less than 1. Right, this is when a geometric series converges. What does that really mean about r? If the absolute value of r is less than 1, what kind of numbers could r be? Describe them for me like on a number line. Where would I be if the absolute...
0.5.
0.5, I like that. 0.5 would work. Where else could they be? Aha, anywhere between 1 and -1, right? Anything between here and here would have a distance of absolute value of less than 1. So if that has to be true, then that has to be true over here as well, right? If it's x, if that's our ratio. And I'm going to write between 1 and -1 like this. X has to be between -1 and 1. Just like we said, r had to be between -1 and 1. That's what we're talking about when we talk about our interval of convergence. So this particular series here is adding a bunch of x terms that keep getting higher and higher exponents. If we want it to converge, we have to pick an x in this range, in this interval. If you pick x equals 0.5, this will be a convergent series. It'll be a geometric with r equals 0.5, that'll converge. If you pick x equals 8, that's outside of this interval, so it's going to diverge. So we call this the interval of convergence. There's an infinite number of x's that will work. Interval of convergence. Any x in there will make this particular series converge. Any x outside of there, it will diverge. Okay, what do we mean by interval of convergence? We also write that in interval notation, if you remember interval notation. Oops, not infinities. -1 to 1. We'll see infinities coming up later. That's an interval from -1 to 1. So that's the definition we have next. The interval of convergence is the set of all x's that make it converge. Using what we know in this case about it being geometric, later on we'll talk about ratio and root tests and whatever else. Yes, Joseph?
So in this case, if we were to put either one of those, like x is greater than -1 but less than 1, or the interval from like -1 to 1, either one of those, would you accept or just the 1 to 1?
Either one's fine. Like if you're working on a WebAssign, it's going to tell you to put it in an interval notation.
Mhm.
My answers will usually be an interval notation. That's just the shortest way to write the answer, but I would take either one. The important thing is it would have to be an and statement. So if you wanted to write, you'd have to say x is greater than -1 and x is less than 1.
But
Can
I
be
mean,
more.
like, what if you wrote it in that same form, like the same one that's right above interval?
Right here?
Yeah,
Oh, that's fine.
that's what I meant when I was
Oh,
saying
yeah.
that.
That's fine too. That's the same thing defining the interval. Okay with the interval? And then we talk about the radius of convergence. The radius is the distance from the center to the edge of your interval. So we already talked about the center of this one is at 0, because it's not x minus or plus anything. 0's in the middle of this interval. How far to the edge? Either way. In this particular example, there's just a distance of 1 from the middle, 0 to 1 or 0 to -1. So in this case, the radius would be 1. How far from the middle to the edge? We're gonna see some specific examples coming up. I just wanted to make sure we're okay with notation on a nice straightforward example to begin with. Questions there? So the next line on your notes, it's all scary, confusing looking with lots of notation. It says A minus R is less than X is less than A plus R. So we actually just did that in this example. What was the center for this one?
0.
Center was 0. So we had 0 minus the radius, and we had 0 plus the radius. Right? The center was A, and A was 0 in this case. So that's what we did to come up with that ratio, that interval. But let's say the center wasn't 4, like this other one I made up over there. If the center wasn't 4, your interval might look like, let me make this up, less than x, less than or equal to 7. Making sure that works. See, that's my interval. If that's my interval, the middle of it is still your center. What number is exactly halfway between 1 and 7?
3.5.
Ooh, halfway between it, so you have to add them up and divide by 2.
Oh.
It's not 0 and 7, it's 1 and 7, so it's actually going to be 4.
4.
Right, 4 is right in the middle, half of 8.
Can't math.
If it was 0, you would have been good. So 4 is in the middle. So A equals 4. What's my R? How far is it from 4 to either side?
3.
3, right? 7 minus 4 or 4 minus 1. So R equals 3. So we could say that this is 4 plus 3, and this is 4 minus 3. Right? That's really saying the same thing. So don't let this notation scare you. It's really saying you're adding and subtracting that radius from the middle. That's all that notation is saying. Questions on that notation? Then there's a couple notes. You could have R equals infinity. If your radius is infinity, that means from wherever the center is, you can go infinitely out to the left and to the right. What would that mean your interval is? If you can go infinitely in each direction, what interval? Yeah, the interval would have to then go from negative infinity to infinity, right? Any possible x you wanted could go infinitely in either direction. That does happen sometimes. There are some power series that converge for any value of x. I don't care what x is, it will converge no matter what. We'll see one of those coming up. You also will sometimes have r equals 0. What does that mean? If r equals 0, how far away from the middle am I allowed to move?
You're on the center.
I'm just stuck on the center. I can't move off the center. So let's say the center was x equals 5. If the center was x equals 5, this radius says, okay, you can't move left and you can't move right. 5 is the only one that works. In which case you would write your interval as just the set of the number 5. There's only one x that makes it converge. We use set notation, there's only one answer. We'll see one of those coming up as well. Those are some exceptions. Most of them will look like this, some range of values, but sometimes they go all the way out to infinity. Sometimes they're just stuck on just the center, it's the only way it will converge. What else do I have in my notes here? Number 3 is a big one on the notes. The convergence of the endpoints of the interval is determined individually for every series. What that means is, so I wrote this one up here, for example. X is between 1 and 7. It might be, for this particular series, that it actually converges if x equals 1, but not if x equals 7. It might be that one side converges and the other side doesn't. In which case, my interval would have been 1 to 7 if we're using interval notation like that. We're going to talk about how to find those, but when you're finding the interval of convergence, I highlight number 3. I write on my notes, you must check the endpoints every time. Without an example, I can't show you what I mean. Well, I suppose we could check it on this one. Let's check it on this one. So remember we were doing this one over here to get the idea, and we got this interval here? What happens if x equals 1? If x equals 1, so I'm just choosing this right-hand endpoint, and I plug it into here. What does my series look like if x equals 1? The sum of 1 to the n, right? Plug it into my series. That's just 1. What do you get if you add 1 forever? That's equal to infinity, right? So does it converge if x equals 1? No, it diverges if x equals 1. If it diverges, then we're not going to include that endpoint. But if this one had converged, we would include it. So that's what I mean by checking the endpoints. This one's actually kind of boring. Neither one works on -1 or 1. I'll show you on some other ones where it's a little more interesting. But you always want to check them. I don't know what my notes in number 4 is supposed to say. I think it just says if you plug in the center, it always works. Which makes sense, because when you plug the center in, a minus a is always equal to 0. And you can add 0 as much as you want. I'm not sure what my point was with that one. And most of the time, we're going to use the ratio or root test. So let's look at some examples. It'll make more sense now that we've got some vocabulary down. So example 1a. That one I didn't use the ratio or root test because I made it look geometric. But look at this one. So here's 1a. I have this power series that's 2 to the n over n times 4x minus 8 to the n. And the directions say find the radius of convergence and the interval of convergence. My first question for you is, where's the center? Centered at x equals what?
2.
2, because that's what you plug in here to make it equal to 0, right? If x equals 2, it's just adding 0 a bunch of times. So the center is whatever makes that equal to 0. So it's centered at, oh, I'm going to put a, and a equals 2. That's the center, because that's what makes this part equal to 0. We know it's going to converge if x equals 2, because we're going to add 0 plus 0 plus 0, no problem. Okay. So we want to really find out when is it going to converge. I'm going to use the ratio test. And I'm going to what I like to call force it to converge. Because I don't know how it's going to converge. But if I'm using the ratio test, we talked about this earlier, which is why I said we'll be seeing some practice. How does the ratio test work?
The one that case of n plus 1 over piece of n.
The limit of the n plus first term over the nth term. So the n plus first term is 2 to the n plus 1 over n plus 1 times 4x minus 8 to the n plus 1. Right, that's the n plus first term. I know it's messy. Over the nth term. Pretty messy. Suggestions on cleaning it up. What can I do to clean that up?
Multiply by
Yeah, so I'm dividing by this fraction, so I can multiply by the reciprocal of that fraction. What about these guys?
Cancel.
Yeah, those are going to reduce, right? I just have one more up here than I do down here. So this is totally gone, and I just have one up here, right? Just one of those left. And so I'm going to do that and flip over this bottom fraction as Joseph suggested to clean it up a bit. So that's the limit of 2 to the n plus 1 over n plus 1 times n over 2 to the n. That's flipping this one over. And I still have a 4x minus 8. 1 for x minus 8. You see what happened there? So what else cleans up nicely here? The two n's are gonna reduce. This is 2 to the n, this is 2 to the n plus 1. So there's an extra 2 on the top. 1 extra 2 up here. Okay. Now at this point, let's not forget our variable here. There's n's and there's x's in here. This is the limit as n approaches infinity. If n is approaching infinity, that's not going to affect this 2. It's not going to affect this x. This is all constant when we're talking about n. N won't change these. So I'm going to pull these things that don't have n's in them, this and this. I'm going to pull that all the way out front, just to get it out of my way because it's messing up my limit. So I'm pulling out a 2 and an absolute value of 4x minus 8. And then I have the limit as n goes to infinity of just n and n plus 1. So I factored out the parts that didn't have n in them because they won't be affected by my limit. Still all right? So now, can you find the limit of this part? Yeah? What's the limit here? Equal to 1, right? This part's just going to 1. So this whole thing is going to 2 times the absolute value of 4x minus 8 times 1. Which is 2 times the absolute value of 4x minus 8. That's my limit. Yes?
Why is the 2 not in the absolute value symbol?
It can still be in there, I just took it out, it doesn't really matter, I can put it back in. His question was, why is the 2 not still in there? I don't know, I took it out. We put it back in and make it 8x minus 16 if you want.
I just wanted to know.
Yeah, no, it's just, I wasn't, it didn't matter, right? When I factor out the 2, it's still a positive 2. So I could have left it in or taken it out.
It would only matter if it was a negative 2?
Right, then it would come out as a positive 2. Right. So remind me about the ratio test. When you use the ratio test and you take the limit, when does the series converge? I've erased my list since we talked about it earlier. Remember, it's like the geometric,
When L is,
just like geometric.
When R is less than
When
one.
R is less than 1, so we want L to be less than 1. So what we're going to do now is what I meant earlier. We're going to force this series to converge. This series will converge when this limit is less than 1. If this is less than 1, series converges if this limit is less than 1. All right there? From here, it's algebra to solve for our interval. I think I'll divide by that 2 since I pulled it out anyhow. So I have 4x minus 8 is less than 1/2. I recommend factoring out anything you can actually to have this just start with an x. So I'm going to factor out another 4 here. You guys okay with that? Factor down the 4? 4 times x minus 2 is less than 1/2. And the whole goal here is to isolate the absolute value. So I'm going to divide by that 4, and I am here. Absolute value of x minus 2 is less than 1/8. So this tells me that x minus 2 is between plus and minus 1/8. So I'm going to write that down. X minus 2 is between positive and negative 1/8. You have to get comfortable recognizing this absolute value notation meaning that you're stuck between a positive and a negative. Just like over here, we took this and said that x was between plus and minus 1. So now that's between plus and minus 1/8. Now we're going to solve for x. We're almost there. How do I solve for x? Add 2 to all three sides. Add 2, add 2, add 2. And we have that x is between, gotta get a common denominator. This is 16 over 8.
15 over 8.
If I add 1, that'll be 17 over 8. And this one, you're right, will be 15 over 8. So the directions were find the interval and the radius of convergence. We actually don't quite have the interval yet. We're close to it though. We're pretty sure that x has to be between these two numbers. Remember what I said about checking the endpoints? We haven't checked them yet. So we don't know if it could equal this or maybe it could equal this. You never know. It might be that it works at this point and not this one. Maybe it works here and not there. Maybe it works for both. Maybe it works for neither. We're going to check those. I claim though that we already know the radius of convergence. Remember the center was at 2. How far from 2 have I moved over here? How far away from 2? 1/8 to the right, 1/8 to the left from 2, right? This actually is your big hint right here. Here's your R. R equals 1/8. This tells you I'm allowed to go 1/8 away from my 2. So that's our radius of convergence. You could also see here, take the middle, which is 16 over 8, and subtract either one, you get 1/8. Okay, so that was most of the work. We're not done. These are very long problems. Questions up to there? This is not my answer. Now I need to check the endpoints in the original series. Check the endpoints in the original series. What I mean by that is take x equals 15/8, plug it into here, simplify, and check to see if this series converges or diverges. And then we're going to take x equals 17/8 and do the same thing. I don't know if I'm going to have enough room in that corner, so I'm going to come over here. So if x equals, I'm going to do the left one first. What was it, 15 over 8? I'm clear what I'm getting is I'm taking these numbers from the edges here. I'm going to take that 15 over 8, plug it in here, in the original series, ever so carefully. So I have the sum, n equals 1 to infinity of 2 to the n over n times 4 times 15 over 8 minus 8 to the n. Is that right? 15 over 8? Yeah. Everybody see what I'm doing there? Now we just need to simplify. Now simplify using your fabulous algebra skills. So this is 2 to the n over n times, what is that, 15 over 2?
Yep.
Minus 8 to the n. So that's 16 over 2?
Negative 1/2.
So it's negative 1/2, he says.
It's not to me.
Ah, he's already ahead of the game here. N equals 1 to infinity, 2 to the n over n times negative 1/2 to the n. 15 halves minus 16 halves is negative 1/2. Keep simplifying. If you don't keep simplifying, you're not going to recognize your series. There's more simplifying to do here. What simplifies?
And the 1/2 and the 2 to the.
Yeah, the 2 to the n here and the 2 to the n denominator here. You see that? Those 2 to the n's and these 2 to the n's are going to reduce. If you think about it,
I got 1 to
I'm going to write this separately this way so you see it better. 1/2 to the n is really this, the top, the negative 1/2. Right, just do the top and bottom separately. So those are gone. So I've simplified and I got all the way down to this series here, which is negative 1 to the n over n. I've read all the way in somehow. So now the question becomes, now that I plugged in x equals 15 over 8 and I've simplified this, does this series converge or not?
Is it conditionally?
It's conditionally convergent, which doesn't really matter because it's either a yes or no. So we don't care if it's absolutely convergent. So because it's an alternating series, we're going to use the alternating series test. And we're going to find out from the alternating series test that the limit of those terms, if you just look at the positive part, is 0. So it's convergent. So that tells me right away that I now know that x could actually equal 15 over 8. That's affecting my interval. I'm allowed to go 1/8 the way, but I could actually make it equal that endpoint. And guess what I have to do next? Same thing with 17 over 8. So now, x equals 17 over 8. I'm plugging in 4 times 17 over 8 minus 8. Oops, I left off all the beginning stuff. Let me squeeze it in there. In the original series, replacing my x with a 17 over 8. Two to the n over n. This is 17 over 2 minus 16 over 2. That's just 1/2 to the n. It's positive this time. What reduces here?
Two to the end.
Yeah, the 2 to the n's are gone. And the 1 to the n is just 1. It's not alternating anymore because it didn't turn out negative this time. So this whole series simplifies down to this. What do we know about that series?
Divergent.
It's divergent, it's the harmonic. So that means that x equals 15 over 8 did work. X cannot equal 17 over 8 because when we checked it, the series diverged. So my interval of convergence, to actually answer the question, the interval is including 15 over 8, but not including 17 over 8. And my radius we already talked about was 1/8. These are long problems. Because not only do you have to do the ratio test with all this algebra, just to solve for this interval, then once you get the ratio test done, you have to check both your endpoints to actually get your interval. And check your endpoints means plug it in, simplify, and brand new question, does a new series converge or diverge? Good, we have time for that. Questions? What's going on there? Okay, so let's give you some special cases. Let's look at B. Let's look at B. What is B? I'm going to erase this part now. have this series, n equals 0 to infinity of n factorial times 2x plus 1 to the n. Where's the center of this one?
1/2.
Negative 1/2.
Yeah, it's centered at a equals 1/2. You plug 1/2 in, oh, negative 1/2.
Negative 1/2.
You said it, I didn't write it. Negative 1/2 in there. It will converge. Because you're adding 0 plus 0 plus 0, so it will definitely converge if a equals that. And then the question is the same, find the interval and radius of convergence. For what other x's does it converge? So what do? How do I force it to converge?
Ratio test?
Yeah, ratio or the root test. Because one has factorials, we definitely want the ratio test. So we're going to use the ratio test here. The limit as n goes to infinity of n plus 1 factorial, 2x plus 1 to the n plus 1 over n factorial times 2x plus 1 to the n. The n plus first term over the nth term. What reduces here?
Factorial and also 2x plus 1.
Yeah, the factorials are going to reduce because this is just one more than this one down here. So this will completely be gone and this factorial will be gone. We talked about that last time. For those of you who aren't familiar with factorials, think about 5 factorial over 4 factorial. Right, one more than this. This means 5 times 4 times 3 times 2 times 1. This means 4 times 3 times 2 times 1. So everything reduces except for that first number. So in this case, the n plus 1 is all that's left.
And the 2x plus 1 to n power cancels out.
Yep, this completely goes. I'm just left with what's there. Bless you.
Bless you.
So this becomes the limit as n goes to infinity of n plus 1 times 2x plus 1. Again, we want to factor out the parts that aren't affected by n. So I'm going to factor out the 2x plus 1. And then I'll have the limit of this part. What's happening here? What's the limit of this part as n approaches infinity? Infinity plus 1? That's infinity, right? That just keeps getting bigger. Whatever number you put in there, we want one more than that. That just keeps blowing up. So I have 2x plus 1 times infinity. So this limit is infinity. Doesn't matter what x is, right? Limit's infinity. Because this guy just blows up. It doesn't matter what's over here. What do we want to be true for the ratio test? We want this limit to be less than 1. How often is infinity less than 1?
When it's less than 1.
Yeah, but it's infinity, right? So this is never less than 1. It's not going to converge. Because that will never be true unless, there's one unless. Except at where? What makes this series converge? We talked about it when we started.
Negative 1/2.
Negative 1/2. Because if x equals negative 1/2, you're adding 0 plus 0 plus 0, it's gonna converge. Except at x equals negative 1/2. That's the only way it will converge is if you're adding 0. You change anything off of that negative 1/2, it's gonna blow up and go to infinity. Never less than 1, which means it diverges except at negative 1/2. So remember the question was the interval and the radius of convergence. Where does it converge? Only at negative 1/2. You can't move off of there, right? So the interval is not even really an interval. It's a set. Negative 1/2 is the only x that works. And the radius tells me how far off of there can I move?
0.
0. So there's your example of when you have a radius of 0. This power series only converges for that one value of x. Any other value of x makes it diverge. So you can start at negative 1/2, but you can't budge. Questions? The last one I do, 6 minutes, I can do it.
How do you
Yes.
simplify n factorial over there?
So I did an example here. N plus 1 factorial over n factorial just means that you started with one number higher than this one. So I did an example with 5 and 4, but it could have been anything. 5 factorial means 5 times 4 times 3 and so forth. 4 factorial means starting with there. That means all of these are going to reduce every time. So even if it was n plus 1 and n, you'd have n plus 1 times n minus 1, all the way down till you got to 1. And n factorial would have been n minus 1, all the way down to there. So no matter what, these guys are all going to reduce. See what I mean there? It's because of the nature of factorials. That's why we do the ratio test for factorials, because they're all going to reduce like that. Other questions? Yes?
So, cancel out the 2x plus 1 to the n, just the n plus 1.
So same idea. This is just one more than this. Imagine if this was a 7 and this was an 8. You have one more up here than you do down here. So 7 of them will be gone. You'll have one less. Yeah, so the variables make it all weird, but if you've got one more of it, then you just got one left and you reduce them. It's not 7 and 8, but I gotta reduce them. But I like to do that. I like to imagine I know the numbers and then I can make sense of how it works. Okay, let's look at the last one real quick because it's another special case. Example 1C. We can do this. Probably have to finish that quiz. 1C has sum n equals 1 to infinity x minus 6 to the n over n to the n. Same question, interval and radius of convergence. We can do the ratio test or the root test. This one's a good one for the root test. Why?
Because ratio test sucks when you do it. I
Why?
decided it.
Oh, you tried the ratio test? Okay, so that's one reason is because Joseph tried the ratio test and it sucked. I don't think that's the mathematical term for it, but we'll go with that. But just by looking at it, what makes it look like a nice root
Because
test?
it's raised to the n.
Yeah, it's everything's raised to an n, so the nth root test was to take care of that. So I'm going to use the root test. Anytime everything has a power of n, I'm using the root test. Otherwise, I'm going to the ratio test. So the limit as n goes to infinity of the nth root of x minus 6 to the n over n to the n. Oops, I forgot my absolute values there. Absolute values are inside there. So you're like, all okay that that root gets rid of these powers out here? That's why we chose the root test. So I now have this. I love the retest, when it works. If it doesn't work, it's a mess. Now I'm going to again factor out the part that doesn't have any ends in it. So I'm gonna pull the x minus 6 out front. And take the limit of this part. What's the limit of this? 0. Right, this part goes to 0. 0 times anything is going to equal 0. How often is that less than 1?
Always.
Always less than 1. Always, that's a really weird arrow. Always true. For any x. Right, I don't care what x you give me, this is gonna be true. So if it works for any x, what's that tell us about this one?
It's from negative.
From infinity or?
It's from negative infinity to infinity. It converges for every x. Converges for all x. So my interval is negative infinity to infinity, and my radius is infinity. So those are the 3 things that could happen. You might actually get a radius and an actual interval with endpoints that you have to check. That happens most of the time. You might end up with a situation where it only converges at that one point at the center and nowhere else. Or it might just converge everywhere, in which case you have this situation. Okay, I will see you on Tuesday. 11.7 is all review. 11.8 is this. And then we're going to do more with power series on Tuesday.
Is 11.7